Good afternoon, everyone. It's Joe at JAS Land Rovers again. Yesterday we asked you a pretty good question. It was a Discovery 3 we had in a couple of weeks ago. It was a really good diagnostic job. It's one we want to share. So I'll just take you through what we did yesterday. This is the question that we asked you on Facebook. This is the picture that was with it. Start off with this picture, and then these are the questions that we asked. Basically we said, the car doesn't run, what's wrong with it? So points that we gave you 6 little bits of information. It would crank, but it wouldn't start. A little bit of information there. If it's cranking, it's not an immobiliser problem. So we're not looking down the immobilised route. A little bit of a red herring here. So point number 2, 4 camshafts, 2 camshaft pulleys, 2 camshaft chains, 1 timing belt. Doesn't really matter in this case. I'm just throwing it out there to mess you up. 3, no faults logged. That was true. We'll just leave that alone for a second. 4, the injectors were firing while the engine was cranking. That was true. So if our injectors are firing, that means that our powertrain control module, the engine computer, believes that everything is right in order to try and start the car. Particularly, it means that we've got camshaft and crankshaft synchronization, and it's seeing fuel pressure. That, coupled with the fact there's no faults logged, is a pretty good indicator that the PCM believes everything's right. Camshaft and crankshaft are synced exactly, etc. Number 5, this was all true as well. It wasn't an electrical problem, an electronic problem, or fueling problem. It could have come down to a faulty PCM, this diagnosis job. In the end, it didn't. But that's just saying from the outset it wasn't any of those things. And last of all, this was a bit more of a clue than you wanted to believe, but it's impossible to install the above pulley. So that was that picture, our camshaft pulley and camshaft trigger wheel. It's impossible to install them upside down or backwards. That's true, absolutely true. That was a bit of a hint for you guys. So moving over to the laptop screen, this is going to be familiar to you from one of the other technical Tuesdays we did, where we had another Discovery 3 in as a non-start. That ended up being an incorrectly installed crankshaft trigger wheel. When we scoped that one, our green here is our crankshaft trigger, and the yellow line here is our camshaft trigger. When we scoped the last one that we did, this camshaft trigger, this drop-off point here, that's our important thing. We'll be looking at that again later. The camshaft trigger, the drop-off, was way over here, completely in the wrong place. That one, however, was logging camshaft and crankshaft synchronization faults, and it wasn't firing injectors while it was trying to start. So different problem, potentially. Essentially, that's where we're up to with this one. This is the scope reading from this non-starter. Our camshaft drop-off here is exactly where we expect it to be, smack bang after this gap in our crankshaft reading, sorry. That's one gap in our trigger wheel, that's another gap, that's another gap. So each gap there is 1 revolution of the crankshaft. That's 360 degrees crankshaft rotation, that's another 360 degrees crankshaft rotation. 2 crankshaft rotations in a 4-stroke engine is 1 cycle, basically. In those two cycles, in those 2 rotations, you have the induction, the compression, the combustion, and our exhaust stroke all in there. That's an important thing to look at. That's our 720 degrees of crankshaft rotation, 1 4-stroke cycle. Synchronized with that, we have our camshaft. It is turning, that's one thing. It's a good signal, it's 0 to 5 volts, that's our digital signal that we're on about. The crankshaft signal is also a 0 to 5 volt digital signal. The signal itself looks good. We've got our gaps in it, they all look good. There's no messing around there. The signals, both signals look good, and they're synchronized. So that's an important thing for us to note right there. I'm just going to refer back to my notes, which I've got in my hand, and you're not allowed to see because it gives the game away. Essentially at this point, with the injectors firing, no fault codes, and we've scoped our cam and crank, and we've got the known, we compared this drop off here to our known good sample that we keep. We have our gap in the crankshaft signal, 1, 2, 3 counts on the crankshaft trigger wheel, then we get our drop off. That is a known good signal. That is a good signal. That should mean this engine is timed up, as backed up by having no fault codes and our injector trying to fire. But our engine isn't running, it isn't firing, it's not going. So what's wrong? At this point, everything says it's timed up, but we don't believe it is timed up. So how can we prove that it's not timed up? Right now I'm just going to ask Steph to swing to the left slightly here and look at these two things. So these are amp clamps. This is quite a big one. This will measure up to 2000 amps. Basically we can put this over a cable and it will measure the current flowing through that cable. This is a much smaller one. This will measure 20 amps very accurately, or 60 amps less accurately. With those two, we are just going to add something onto our screen over here. I'm just going to zoom out slightly, and you'll see what's going on here. And I'll zoom out again. So that's our whole capture from this car, from initial cranking the engine over to turning it off again. That's our whole capture. This tells us, or gives us a big clue as to exactly what was going on there. So I'm just going to zoom in there. We can ignore our crankshaft for now, that's off the screen. Ignore the camshaft even though it's on there, just forget it for now. The thick blue line, that is from this big amp clamp. That is reading our starter motor current. So right here is when we started cranking the car. A lot of current draw to get the engine moving, and then less current as we go on. So this is as the engine is turning over here. Each one of these spikes, these smaller spikes, is each cylinder's compression stroke. So the engine, the higher this spike, the more current is being drawn. So as the engine is compressing one cylinder, it takes more current. Then it stops compressing that cylinder, and the current comes down. Then it compresses the next one, then the next one, then the next one, then the next one. That's pretty much what we'd expect to see. This is a good, we would call it a relative compression test. All of them are fairly even, other than this massive spike to start the engine moving, but that's typical, that's normal. The next channel, if you look at this small little red line down here, that's from this amp clamp, the smaller one. That's measuring current in our injectors, specifically the injector in cylinder number 1. And I'm just going to zoom in much closer onto that one, right over here. So that's spread it all out a bit, but that's the same spike that we had before. That's our cylinder coming up, compression, top dead center, goes down again, top dead center again, goes down again on the next cylinder. This was our first clue really as to what's gone on here. So these two red spikes, those are injection events on cylinder number 1 or injector number 1. This is our pilot injection, and this is our main injection event. That's 2 injection events per firing. Right now our engine's going fairly slowly, so they're quite spread out, and quite small injections because it's only trying to start the engine. We're not revving, we're not accelerating, it's just trying to start. But importantly again, these injection events are after top dead center. Here is top dead center, the highest point of that spike, and our injection events are after top dead center. That's important, and that proves we do have a timing problem. But where is that timing problem from? Because we've got no timing related faults. We've scoped our cam and crank signals and they both synchronize perfectly fine. So what is going on there? Information to add on to that then. So, well, rather at this point, if our injection events are late, as in not at the right time, but the engine is timed up correctly, at that point we could have a bad PCM, a faulty PCM. That could be faulty. Just clear that for you guys. Or our trigger wheel could be installed incorrectly, but our cam and crank signals are good. So how do we get around that? We know the engine's been out and it's been rebuilt. We have had incorrectly installed trigger wheels before. At this point, just move back onto the photo over here, Steph. So this was my little eureka moment. I was staring at this trigger wheel as it was installed into the engine for quite a while, staring at it, and then I realised that each one of these lobes, this lobe here, and this lobe here, and this one here, they're identical. The gap in between each one is identical. Effectively, as the sensor looks at the back of that plate, it will go from 0 to 5 volts as this bit goes in front of it, then it will pass in front, and then it'll go back to 0 volts when the gap appears, then it'll go back to 5 volts again, stay at 5 volts, go back to 0 volts, and so on. So that's how we get our repeating 0 to 5 volt digital signal from those 3 lobes. But as I say, they're all identical, and that's why we get, just come back over here, Seth, sorry. Just to reinforce that, here's our yellow signal, that's our camshaft. Here's the gap in the wheel, there's the lobe on the wheel, gap in the wheel, lobe on the wheel, and it repeats, and every single one is identical. This is what led me to realise that the PCM, the powertrain control module that controls everything, cannot tell the difference between this camshaft lobe and this camshaft lobe and this camshaft lobe. And just to put that back on the picture, it can't tell the difference between this one, and that one. As far as a digital signal is as far as the camshaft signal is concerned, each one of those is identical. It can't tell the difference between them. So we know from this engine, this engine bases everything off the crankshaft trigger wheel. It assumes that cannot be wrong. It assumes that no matter what else is wrong with the engine, the crankshaft cannot be wrong. It cannot be incorrectly installed, etc. If we quickly, what we'll do now is just go back to only looking at our crankshaft and camshaft signals, and we're just going to do something over here, which will show you what I'm talking about. So, going back to here's 0 degrees. That's where we start. There's 360. That's 720. This drop off here is identical to this drop off here, and identical to that drop off there, and this one over here, for example. So, what we can do with the scope here, if I grab that little cursor and move it across, put it about there. So right now, we've got this gap here at 0 degrees, and another line here right before this drop off. And if we go over here and look at this little box, Steph, you might have to zoom in on that one. That little box says 242.7 degrees. Let's call it 240 degrees. 240 degrees crankshaft rotation. After 0 degrees, there's another camshaft drop off. So, if you put it all together, this is where it gets confusing. 240 degrees rotation, and we've got 3 lobes on there. They're identical. It's meant to trigger off of this one, for example. 240 crankshaft degrees later, along comes this one. The PCM cannot tell the difference between the correct lobe and the incorrect lobe. So what we've got essentially, as Steph's moving that around helpfully, thank you. What we've got there, or what we think we have, what we want to see when we get this gearbox off this engine, and this is where we're going, is an incorrectly installed crankshaft trigger wheel again. We want to see the same problem, but to prove that what our reasoning is right, we want to see the trigger wheel installed 240 degrees, or 2/3 of a turn, incorrectly. It needs to be 2/3 or 1/3, if you like, out of position. So, throw that one away. Just look at this picture. So this is what we got when we took the gearbox off the back of the engine. Here's that crankshaft, the shiny bit. The trigger wheel goes around the outside, that kind of browny thing. There's our hole, our alignment hole, and that yellow mark there is where that hole should have been. And here's something that makes it easier. Here is the actual trigger wheel off that engine. Here's our alignment hole, that's where it should be. We just stick the alignment hole at 12 o'clock. This one's down here. If we split that up into 3, and I've got my finger about there, that's a fairly good. Here's 120 degrees, here's another 120 degrees, there's back to 360. So that mark is where it should be, that's where it was, that's 2/3 out, 1/3 out, 2/3 out, 1/3 out, exactly what we wanted to see. Come back to me now, Steph. So That was the answer, incorrectly installed trigger wheel. But how anyone could install it exactly, precisely 240 degrees out, that's the only point they could have put it where it wouldn't log faults. It wouldn't log faults, the PCM would see crankshaft and camshaft synchronization, and it would try and fire the injectors and it would try and start. Everything pointed to this car being timed up correctly, but it wasn't. The scope helped us with the cranking amps and showing top dead center, and then the injection event being after top dead center. That proves we've got an incorrect timing problem or a faulty PCM. It turned out not to be a faulty PCM, potentially not logging faults when it should have been logging faults. It turned out not to be that. It made sense that it wasn't. When we figured 240 degrees later on the crankshaft, and we saw the 3 lobes on the camshaft, that was a pretty good indicator that that's what we're looking at. That's the end of this video. Another one with a badly installed crankshaft position sensor. Watch out for it, guys, it's out there. Well done to the guys who got it right. Alan Thrower, you were on the money. A chap from Hungary whose name I cannot say, I apologise, you were on the money as well. Michael Adamson, you guessed it, you lucky git. But there you go. Well done, guys. We'll see if we can do another one of these in future. Sorry for the long video.